Good afternoon. My name is Shamwave. This is my partner, Paul Bowen, and today we are doing our presentation for an elevator. This project focuses on the design, operation, and control of an elevator system. It aims to demonstrate how automation safety, efficiency can be achieved using basic electronic components, microcontrollers, and programmable logic controllers. The purpose of this elevator project was to develop a functional model of an elevator that mimics real-world behavior, including floor selection, door operation, and safety features. By combining mechanical components with electronic control systems, the project offers insight into both the engineering and programming aspects of an elevator operation. Our inspiration for this project mainly came from hearing that someone else tried to do an elevator, and we heard it was a bit challenging for them, so we wanted to see if we can also not only do what they did, but do better than what they did. Right. Here's the AS bridge with a 12-volt supply going into the motor. Over here we have a combination of call buttons for floor 1 and 2. We have limit switches for floor 1 and 2. And then we have servo motors which will open the doors on floor 1 and 2. We have the inputs going to the Arduino, which would, say we press call button 1, and when the elevator goes up to limit switch 2, it will start the elevator, and vice versa from floor 1 to floor 2. And here we have the real world aspect instead of the drawing for the circuitry for our elevator project. I'm gonna hand it over to my partner, Paul Bowen now.
Good afternoon. All right. Here you're looking at the picture design from Fusion 360 of the actual elevator shaft, as well as the gear that would attach the DC motor, which would call up and down said elevator shaft. This here is a picture of the actual functioning elevator from the shaft design, the cable attached to the gear, attached to DC motor, which is mounted onto a wooden frame, which will also have 2 buttons mounted to call up and down the elevator shaft from the bottom floor to the top floor, then from the top floor to the bottom floor, as well as the circuitry, the Arduino, as well as the circuit board, which controls every aspect of the elevator. These are some pictures, some close-up pictures of the said DC motor mounted, the gear, the cable. This is a picture of a 3D printed frame for the servo to open the doors, actual doors of the elevator. And this here is a picture of the frame, the elevator frame, which was also 3D printed. This is a close-up of the servo itself, attached to a gear, which is also attached to a rack, which would have been attached to a door. So as the gear of the servo turns, the rack would pull said door forward, which would then cause it to open the elevator shaft, so people would be able to enter, and then the servo gear would turn, and then the rack would go pull back out, causing the door to close. There's a video of that operation of the rack and the gear moving clockwise and counterclockwise. And this is a video of the actual DC motor pulling up and down the shaft via the gear attached to the wire. So as the shaft comes down, there is a limit switch, electronic device attached to the bottom of the shaft, which when the shaft, bottom of the elevator frame, which when it hits the shaft, it will cause the shaft power to shut off and the shaft will now reach the bottom floor. Right. Possible improvements that could have been made. Initially, we wanted a sensor that would have been attached to the frame of the elevator, where if someone tried to come within a certain distance and try to stick out their hand, the sensor would detect the person and the doors would open if the button was already pushed to carry it up to a floor. It's closed. We wanted also to design actual doors for the elevator, which would have earlier said to attach to the servo, which would have opened and closed based on the direction of the gear, the servo gear. And we also wanted to add a third floor to the elevator instead of just the first floor and the top floor. What we learned doing this project, we learned how to utilize various electronic components, how to use an H-bridge, how to use the OpenPLC software, which we use to design the ladder logic to control the mechanisms of the elevator via laptop or computer, how to set the speed, the actual speed of the DC motor to control the shaft, how fast it goes up and down, how to use an LCD display for the elevator shaft, which we have mounted on the shaft itself to signify which floor the elevator shaft is currently on, and how to send singular motion inputs to the motor. In conclusion, making this project was a fun but very, very challenging process that came with a lot of surprises, things that we couldn't detect at first. And once we detected those problems and we solved them, another problem arose and we had to then troubleshoot in order to fix that problem. So it was all in all a very unique learning experience. And with each problem, it required some determination, some effort, some various research, as well as some creativity to solve. But we both believe that with this accumulated knowledge, any kind of future projects we would embark on, whether it be recreational or any professional, career-driven field, we would tackle them with much better understanding, and hopefully we would do well with any future endeavors we will have. All right.
Also, we would like to thank Mr. St. Rose for helping us build the frame, and we would also like to thank Mr. Nichols as well.
Let's see what.